Hello, my name is Najla, and the structure I chose is the vessel. The vessel is a structure and visitor attraction built as part of the Hudson Yards redevelopment project in Manhattan, New York. It was designed by Thomas Heatherwick of Heatherwick Studio, and it took 2 years to build, opening in 2019 and eventually closing in 2021. For the base form, I started off with a circle in which this circle would determine the widest point of the form itself, and it can be manipulated with a number slider. I then moved the circle upwards 3 times with the distance being able to be manipulated by the number sliders as well in order to determine the distance between the base and the middle and then the middle to the top. I then found the center of each of these circles and scaled them so that it would taper, starting with the smallest at the bottom and then the biggest at the top. And again, all of these sizes can be manipulated with these number sliders. I then lofted all 3 of these circles in order to create one continuous surface. The vessel itself is divided into levels. I was able to do this by using the isocurve battery, in which I was able to divide the lofted surface into different levels, and this can be manipulated with this number slider as well in order to increase or decrease the amount of levels. For the actual design of the building, we can split it up into an outer weave and an inner weave. For the outer weave, I started off by dividing the isocurve into a set number of edges. I started off with 20, but we can manipulate it to be even more or less. And then I sifted these values or these points into pairs so that we are able to create pairs that either stick together or they move upwards slightly. And then by weaving the movements of these points, we are able to create a polyline that connects all of these points together. The inner curve follows the same logic and it builds on it. So by taking the points that were moved slightly upwards and splitting them, and again weaving them and connecting them with a line, we are able to create another set of lines that continue the original set of lines we have. This is what both sets look together, but at this point they are all on one surface and we want to offset it in order to create an inner layer and an outer layer. This is where scale and U comes in. By using scale and U, we are able to create an inner layer and an outer layer that can be manipulated with this number slider, either increasing or decreasing the surface area. Finally, once we have these lines where they're meant to be, we are able to treat them separately by merging, meaning creating two separate lines that can be lofted in order to create the actual surfaces prior to any thickening. And the same logic is applied to the inner layer in which they are merged and then lofted in order to create the surface. And then finally, they're both offsetted in order to create the floor thickness, which can be manipulated with a number slider. Another important factor is creating the railings, which we took from the merge lines and then extruded in the Z direction to create railings. This is what it looks like put together with the railings as well as the thickness of the floor slabs. But in order to add more detail, we want to add staircases. Both the inner staircase and the outer staircase follow the same logic, in which we determine the edges of the floor plates and then join them as curves and then lofted them in order to create singular continuous surfaces. Then, by deconstructing and dispatching the surface, we are able to split it into two, either the completely planar or flat surfaces, which are the flat floor slabs, or the tilted surfaces. These tilted surfaces are where the staircases are meant to be. By focusing solely on these surfaces, we are able to add a surface box to it, in which we are able to morph it with a B-rep of the modeled staircase, in which the staircase would fit perfectly within the floor plates themselves. This is what it would look like with the staircase with the floor plates and the glass railing, bringing the building together. In terms of the attempt at incorporating Kangaroo, it started by connecting the lofted base surface to a move component, which allowed us to deconstruct the B-rep, and eventually connected to a Weaver Bird join meshes in order to join a large number of meshes together. This was connected to a bouncy solver, which was in turn connected to mesh to poly surface, and eventually a deconstruct BREP, which was reconnected to our ISO that was the base of our structure.